So continuing with the previous section of this topic, our next type of rocks are metamorphic rocks. In part 1 of this lecture, I told you that rocks can be classified as igneous rocks, sedimentary rocks, and then third is the metamorphic rocks. Metamorphic rocks, as the name says, metamorphism, changes. So these are, in fact, you can say developed from the existing rocks. And these existing rocks could be either igneous or sedimentary. By metamorphism. Due to physical, chemical, and biological agents. So whether you have igneous rocks or sedimentary rocks, over the time, because of the physical factors, physical agents, chemical factors, biological factors, these igneous or sedimentary rocks, they undergo certain changes, they undergo metamorphism, and ultimately result in the formation of metamorphic rocks through heat and pressure. So you can have the nascent igneous rocks, you can have the metamorphic rocks which are developed from igneous, you can have the metamorphic rocks which are developed from the sedimentation rocks. So this is how the rocks can be described. This was description of the rocks. Now classification. When we have to classify the rocks, first of all, igneous rocks. So as I said, igneous rocks formed from cooling and crystallization of molten magma. And this molten magma, it can be volcanic or it can be plutonic. And when it is volcanic, we call this as extrusive. So igneous rocks which are extrusive or igneous rocks which are intrusive. Now what is the difference between these two? Extrusive and intrusive igneous rocks. First difference itself is that these extrusive rocks are formed from the volcanic matter, whereas intrusive rocks, they are formed from the plutonic matter. And here it solidifies above the earth, solidifies above earth's surface. So that's why we call it as a volcano, like volcano, and that's why I said volcanic. These are fine grained, that means their size is small, and fast crystallization. Their crystallization is fast. And examples are basalt, andesite, and dacite. On the other hand, plutonic or intrusive type of rocks, these are formed below the Earth's surface. And here it was fast crystallization, so here it is slow crystallization, because these are formed below the earth, so the process of crystallization is slow, and these are fine grained, so here these are coarse grained. And here the examples are granite, gabbro, granite, gabbro, and syenite. So these are the examples of intrusive igneous rocks. So again I repeat, igneous rocks could be extrusive when these are developed from volcanic material. These could be intrusive when these are developed from plutonic material. So that means in case of volcanic, these solidify above the earth's surface. These are fine grained, fast crystallization. Examples are basalt, andesite, dacite. And here the plutonic material or intrusive type of igneous rocks, these are formed below the earth's surface, and slow crystallization, coarse grained, and examples are granite, gabbro, and syenite. This is how we can classify the igneous rocks on the basis of mode of origin. And second is on the basis of chemical composition. When we classify igneous rocks on the basis of chemical composition, then we can say that these could be either number one, acid igneous rocks. When we say acid igneous rocks, the silica content is silicon content is more than 60%. And examples are granite, tonalite, I will write over here, granite, tonalite, and rhyolite, dacite also, dacite, and yes, rhyolite. So when the silicon content is more than 60%, we call these rocks as acid igneous rocks. Then we can have neutral igneous rocks. When silicon content is between 50 to 60%. And here the examples are syenite, diorite, syenite, diorite, etc. And third type of rocks are basic. So acid, neutral, and basic when silicon content is less than 50%. And here the examples are syenite, gabbro, basalt. So igneous rocks can be classified on two bases. First is on the basis of their mode of origin, second is on the basis of chemical composition. Then coming to the classification of sedimentary rocks. And sedimentary rocks can be classified either as fragmental or mechanically formed. Fragmental means mechanically formed. It's in fact a mechanical breakdown. Mechanically formed. And here these are formed by deposition and cementation of fragments. Deposition, and as I said, because all the sedimentary rocks, they are formed by deposition and cementation of fragments. And vary, of course, they vary in texture and size. So examples are conglomerates. Conglomerates are rounded fragment. Rounded fragments. Coarse grained. And the dominant mineral is quartz. After conglomerates, we have another example, breccia. So these are angular fragments. These are rounded fragments, these are angular fragments. Then after breccia we have sandstone. Sandstone, they are in between the coarse grain, in between coarse grain and fine grained shale. So shales are of two types, coarse and fine. In between we call these as sandstone. And then arkose. Here look, it's quartz and feldspar dominant sandstone. This is sandstone. Dominant in feldspar and quartz. In fact, you know, the name, even not only the name, the structure and composition, it describes the type of rock. So here, because of the dominance of feldspar and quartz, of course it's sandstone, but dominant in quartz and feldspar, we call this as arkose. And then shale. Shale, in fact, are the finer, formed from the finer material. These are fine grained, mainly you can say silt and clay shales. So these are the shales of the size silt and clay. So this is how the sedimentary rocks first form is fragmental. After fragmental we have chemically formed. Because fragmental, as I said, these was mechanically formed. Now, the second part is the sedimentary rocks which are formed chemically. So here it is, chemically formed sedimentary rocks. Again, in chemically formed sedimentary rocks, it could be inorganically formed and it could be organically formed. So inorganically formed, it could be by evaporation, and examples are here halite. Halite is basically the rock salt. You might have seen this, very commonly found. And this is more soluble. And then it could, second example is gypsum. So difference between this is less soluble, this is more soluble. So this is inorganically could be formed by evaporation, and it could be by precipitation. Those which are formed by precipitation, that means rainfall, these are limestone and dolomite. Here examples are limestone and dolomite. So chemically formed, it could be inorganically, organically. And organically, yes, organically formed, these are formed due to accumulation and partial decomposition of organic matter. Partial decomposition of organic matter. As the name suggests, these are organically formed, and of course under anaerobic conditions. And here the examples are peat, generally we say peat soils, rich in organic matter, lignite, then anthracite, what you call as coal, and coal. This is hard coal, then bituminous, and semi-bituminous. So sedimentary rocks, fragmental, mechanically formed, which we discussed earlier, chemically formed. Chemically again, it could be inorganically, organically. Inorganically again, if it's due to evaporation, then you have halite, what you call as rock salt, and gypsum, that's calcium sulfate. Halite is more soluble, gypsum is less soluble, and if the inorganic process is because of the precipitation, then you have limestone, dolomite. If it is organically formed, sedimentary rocks, then it's because of accumulation of and partial decomposition of organic matter. Then such type of rocks we call as peat, lignite, anthracite, bituminous, semi-bituminous materials. So then after this we have the last one, that is metamorphic rocks. Classification of metamorphic rocks. So this can be gneiss. First group is gneiss. These are crystalline, bended appearance. So gneiss is crystalline, blended appearance. Examples are feldspar, quartz, mica, biotite, and muscovite. These are the dominant minerals. So this is first group of metamorphic rocks, which are crystalline, they have bended appearance, and these are dominated minerals are feldspar, quartz, mica, biotite, and muscovite. Second group is schist. These are finely foliated. I hope you understand foliated. That means very fine layers. foliated, or they also call it as laminated rocks. Why laminated? Because if you remove one layer, you can remove another layer. So just like you have lamination on a particular thing. And examples, the minerals are mica, chlorite. These are in fact the dominant minerals. Mica, chlorite are dominant minerals. Then after this, the third group is marble. Marble is non-foliated. We use marble in our homes. Non-foliated, crystalline rock. Just like gneiss, it's also crystalline, non-foliated. And here the dominant minerals are calcite and dolomite. Calcite and dolomite are dominant minerals. And the last group is slate. So you can see the metamorphic rocks. As I said, these are formed by the changes, metamorphism of igneous and sedimentary rocks, gneiss, schist, marble, slate. And slate is very fine foliated. Fine foliated. Even finer than schist. Splits into thin sheets because it's foliated. And examples are dominant minerals are mica, quartz and chlorite. Are dominant minerals. This is how we characterize different types of rocks and classify these rocks. So I have split this lecture into two parts. Another third part of the same lecture will be characterization and classification of minerals. So that we will be doing in our next lecture. So thank you very much.